Last lectures we have studied the concept of limits. Now today we will see the concept of discontinuity and differentiability. So continuity of function at a point. So continuity of the function at a point, meaning of that whether the given function is continuous or discontinuous at that point, that is if we draw the graph of that function and if there is the gap in the graph at that function, then we say this the function is discontinuous. If graph is coming continuous, then the function is continuous. So if we draw the graph of the function, suppose function f of x and graph is continuous, if we consider any point x is equal to a, so at x is equal to a, the graph of this function f of x is continuous, no any gap, so we say this the function is continuous, f of x is continuous at x is equal to a. Suppose the graph of the function is coming like this. The function is defined in two ways. Suppose this f1x function, x is equal to a is the point, and here again the graph starts here like this. Suppose this function f of x is the f2x. Now here this function totally again the continuous at x is equal to a. So f of x is continuous at x is equal to a. Now here, if we consider, suppose the graph is coming like this, the point here x is equal to a. Now here f of x is discontinuous at x is equal to a. So if we plot the graph of the function and if that graph is coming continuous without any gap, then the function is continuous. Now if we see the mathematical definition of continuity, So first definition, suppose how the function is defined. So suppose f of x is given some equation here for x not equal to a, and that is equal to the value of this function f of a for x is equal to a. So if the function is defined like this, function f of x is continuous at x is equal to a if limit x tends to a f of x equal to f of a. So meaning of that, for this type of the function, that is function is defined for x not equal to a and for x is equal to a, for that type of the function, limiting value of the function, limit x tends to f of x, that is equal to value of the function at x is equal to a, then f of x is continuous. The function f of x is continuous at x equal to a if limit x tends to f of x is equal to f of a. Now suppose the function is defined like this, f of x is some equation here, this is for x less than a, x is greater than a, or maybe greater than equal to a. Now for this function, the function is continuous. So f of x is continuous at x is equal to a if limit x tends to a f of x a minus, limit x tends to a minus means x less than a. So this function will take here is equal to limit x tends to a plus means x is greater than a. So this function we consider for here limit. So f of x equal to f of a. F of a means the value of function at x is equal to a. Now suppose the function is defined like this. The value of the function, what will be the equation here of the function? In that equation we put x is equal to a and we find the value of this function. Now here, if this left hand limit is equal to right hand limit is equal to value of function, then the function is continuous at x is equal to a. Now here, limit left hand limit is equal to right hand limit, meaning of that the limit is existing, and it is equal to the value of function. Now suppose sometimes f of x is suppose defined like this. Some equation for x less than a, some equation for x greater than a. Now to check the continuity of this type of the function, how we'll find it? So f of x is continuous at x is equal to a if limit x tends to a minus f of x is equal to limit x tends to a plus f of x equal to f of a. Now here the problem is arises how we find the f of a. For this x tends to a minus left hand limit, we will consider this equation here, that is the equation of the function which is defined for x less than a. For x tends to a plus, we will consider the equation of the function which is defined for x greater than a. Now here you have difference here. Here x is greater than or equal to, meaning of that this function is defined for x is equal to a, also for the values greater than a. But here no anywhere the function is defined at x is equal to a. So by direct method it is not possible to find the value of function. So and f of a for this type of function will find the average value 1 upon 2 limit x tends to a minus f of x plus limit x tends to a plus f of x. Now suppose if limit x tends to a minus f of x is equal to limit x tends to a plus f of x, meaning of that left hand limit value is equal to right hand limit value, but this is not equal to the value of function. For this situation the function is discontinuous, then f of x is discontinuous at x is equal to a, and discontinuity is removable. And can be removed by redefining f of a equal to limiting value. Next possibility in the study of the discussion of the continuity, suppose situation is coming like this: if limit x tends to a minus f of x is not equal to limit x tends to a plus f of x. Meaning of that, left hand limit is not equal to right hand limit, then not essential to find the value of function. Then f of x, here limit is then f of uh, limit x tends to a f of x does not exist, and f of x is discontinuous at x is equal to a, and discontinuity is irremovable and cannot be removed by any way. सो काही करून शकेल ह्या केसमध्ये आपल्याला डिस्कंटिन्युटी रिमूव्ह करता येत नाही. ह्या केसमध्ये आपल्याला डिस्कंटिन्युटी रिमूव्ह करता येते. लिमिट जर ऍडजस्ट होत असेल तर डिस्कंटिन्युटी रिमूव्ह करता येते, पण लिमिटच जर ऍडजस्ट होत नसेल तर तो फंक्शन ची डिस्कंटिन्युटी रिमूव्ह करता येत नाही, तो डिस्कंटिन्युअसच राहणार आहे. सो दिस इज द मेथड टू स्टडी द डिस्कंटिन्युटी ऑफ द फंक्शन.